Hello everyone. Today we'll learn about zero-touch provisioning, ZTP. ZTP enables unconfigured devices to load version files automatically at startup. When using conventional methods to deploy network devices, administrators need to configure each device manually on-site after hardware installation is complete. This approach is inefficient and prone to errors, especially if a large number of devices are geographically scattered and incurs high labor costs. Although the existing plug-and-play function can be used to remotely commission devices in a centralized manner, it is not widely used on live networks because it depends on proprietary protocols and requires an NMS. ZTP was introduced to address this problem. An unconfigured device enters the ZTP process at startup and uses DHCP to complete automatic deployment. ZTP does not depend on proprietary protocols, nor does it require an NMS. One ZTP process loads the system software, configuration file, and patch file at the same time, making deployment more efficient, cost-effective, and simple. The ZTP function is enabled by default, with the ZTP process being executed only on unconfigured devices during startup. It's not executed if the function is disabled or a configuration file already exists on the device. Before executing the ZTP process, ATN series devices check whether they have pre-configuration scripts. If they do, they execute these scripts before entering the ZTP process. After the ZTP process starts, the device uses DHCP to obtain information such as the temporary management IP address, default gateway address, and intermediate file server address from the DHCP server. The device then downloads the intermediate file, which is an ini.cfg or Python file from the intermediate file server. The intermediate file contains the IP address of the version file server and version file information. The device parses the intermediate file to determine which version files it needs to download from the version file server, and then sets them for the next startup. Automatic deployment is complete once the device restarts. In this process, the DNS server is used to provide the mapping between the domain name and IP address of the file server. ZTP supports IPv4 and IPv6 address applications through DHCP. Configured options are carried in DHCP messages to obtain information from the DHCP server. In IPv4 scenarios, the request messages sent by the DHCP client carry option 60 and option 61. Option 60 carries information about the device vendor and model, whereas option 61 carries device ESN information. Option 1, option 3, and option 6-7 are mandatory in the messages responded with by the DHCP server. Option 1 is used to set the subnet mask of an IP address. Option 3 is used to set the egress gateway of the DHCP client. And option 67 is used to set the intermediate file name. If the name contains a relative path, option 66 is also required and is used to set the hostname of the intermediate file server. In IPv6 scenarios, the request messages sent by the DHCP client carry option 6, which is used to carry the option code requested by the client. Option 5 and option 59 are mandatory in the messages responded with by the DHCP server. Option 5 is used to set the requested identity association address, IPv6 address, and lifetime, and option 59 is used to set the intermediate file path. Now, we'll describe the content of the intermediate file using the .ini format as an example. The number sign SHA-256 sum field indicates that the intermediate file uses the SHA-245 checksum. The begin router and global config fields mark the beginning of the file. Delete the first line containing number sign 256 sum from the file. move the following Part 1 line above, and write #SHA 256 sum plus the generated SHA 256 checksum at the beginning of the file. The file server field indicates the server directory from where the device can obtain version files through TFTP, FTP, or SFTP. The device N description field marks the beginning of the file information description, where N indicates the device number. The ESN and MAC fields indicate the ESN and MAC address of the device respectively. You can obtain them from the nameplate on the device package. The device type field indicates the type of the device. The system software, system config, and system pat fields indicate the system software name, configuration file name, and patch file name respectively. The end router field marks the end of the file. Next, let's talk about how a device implements the ZTP process. When an unconfigured device starts up, the ZTP process is automatically executed. After the system prompts you several times indicating that configuration initialization is complete, the ZTP process is complete. You can then run the display startup command in the user view to check whether the startup files are the same as the specified ones, and run the display ZTP status command to check the ZTP status. You can also access the ZTP folder in the CF card directory to view ZTP logs, which provide useful information about ZTP process execution. This is a brief introduction to ZTP, a universal batch deployment function. In the 5G era, ZTP will play an increasingly important role as the network scale increases.